Hey Finxters! In the previous video, we learned how we can access the children of a tag. Now it's time to learn how we can access the parents of a given tag. Now in order to access the tag's parent, you have to use the .parent attribute. Now let us have a look at an example to understand the .parent attribute. Let us try and access the parent of the title tag, which is head. Before that, let us clear the output window. Okay. Now let's use the print statement, and then we have the soup object dot title dot parent. That's it. That was simple, isn't it? Now let's execute our code, and as you can see, the head tag has been displayed. Now to further clarify things, let us use the .name attribute so that we can visualize the name of the parent instead of the entire head being displayed along with the title, that is the child of head. Now in this case, when we use .name, we should only have head as our output. So let's have a look at that. And as you can see, we have successfully derived the parent of the title tag, which happens to be head. Similarly, let us try and find the parent of the body tag. And now as you can see, the parent of body tag is HTML. Now can you guess what would be the parent of the HTML tag? Any guesses? Okay, time's up. Now let's check the output. And as you can see, it's document. That is the entire HTML document. So if you remember where we discussed our parse tree, the parent of HTML was document, and that is what has been displayed on the screen. Now to further clarify things, let us try and visualize what's document, and therefore let's remove the name attribute and just use soup.html.parent. Now let's execute our code. And as you can see, the entire HTML document was returned to us. Now can you guess the type of this HTML document? Let's try and check that. Let's use type. And now let's check the type. Let's execute our code. And as you can see, the type is the beautiful soup object itself. So this means the parent of HTML is the beautiful soup object itself. You might be wondering, what is the parent of the beautiful soup object? Now let's check that as well. Let's print soup.parent. And as you can see that the soup object or the beautiful soup object has no parents. So I hope this concept was clear. Now what if you want to find all the parents of a given tag? For example, we have the paragraph tag or the p tag within the body, and now we want to find all the parents of that p tag. So in order to do that, you have to use the .parents attribute. Now let us have a look at that. We have to use a for loop in order to print or iterate over all the parents present for the tag. So for parent in soup.p.parents, and then we print parent.name. So we are basically iterating over all the parents for the paragraph tag and then printing them one by one. So let's have a look at that. Let's execute our code. And as you can see, paragraph has the following parents. So the immediate parent is body, the parent of body is HTML, and finally document is the parent of HTML. So this is how you can use the parents attribute and find all the parents for a given tag. Now you can compare this to your family. For example, if you use the dot parent attribute, you will get the name of your immediate parent, for example, your father. But if you use the dot parents attribute along with the for loop, then you'll get the name of your father, your grandfather, your great grandfather, and so on. So I hope this was clear now. Now we know how we can use parent and dot parents attributes to navigate to the parent of a particular tag or an element in the HTML document. What about siblings? How can we navigate to siblings of a given tag? This would also mean how can we move sideways in our HTML document. So let us have a look at the different methods that we have at our disposal. Now before we move on to the code, let us try and understand what is a sibling. So let us move into our HTML code. Now let's consider the bold tag. The immediate sibling of the bold tag is the string text. Therefore, as soon as we print the next sibling for the bold tag, we should have the string text. Similarly, as soon as we try to print the previous sibling of the bold tag, we should have this string as the output. So let me repeat this once again. The previous sibling to bold tag is this paragraph has a, while the next sibling to the bold tag is text. Now let's try and extract these siblings in our code. So now let's use the next sibling attribute in order to find the next sibling for the bold tag. So print soup.b, which represents the bold tag, and then let's use the attribute next underscore sibling. This should print the next sibling for our bold tag. Let's execute the code. And as you can see, as expected, text is the next sibling for the bold tag. Similarly, you can use the previous sibling attribute to print the previous sibling for the bold tag or any tag that has been given to you. So soup.b.previous sibling. Now let's check the output. And as you can see, this is the previous sibling for the bold tag. Now what if you want to find all the next siblings or all the previous siblings for a given tag? For example, suppose you want to find the sibling for the image tag. So let me highlight the next siblings for the image tag. So these are the next siblings, while all the previous siblings are these. So I highlighted them one by one so that you can visualize them. So the portion that is highlighted now are the siblings that are previous to the image tag, while the portion that I'm highlighting now are the siblings that are next to the image tag. Now please note the difference. I mentioned the siblings. I didn't say the sibling. If I said the next sibling, then this would have been the next sibling for the image tag. However, it also has other siblings. So I highlighted all the siblings that come after the image tag. Now let's try and extract all the siblings that are present before and after the image tag. Now in order to do that, you have to use the attributes dot next siblings to find the next siblings of a given tag and dot previous siblings to find the previous siblings of a given tag. So let's use a for loop for sibling in soup.img because we are trying to find the next siblings for the img tag, and then next siblings, and then let's print sibling. Now let's try and execute our code. And as you can see, all the siblings for the image tag have been displayed on the screen. Now let's try and find the previous siblings for the image tag. So instead of using next siblings, all we have to do is use previous siblings within the for loop. Let us comment this out so that we can visualize the output. Okay, now let's execute our code. Oops, I have a spelling error. Okay, now that should be good enough. Let's execute our code again. And as you can see, we have successfully derived the previous siblings for the image tag. Let's cross-check once. Therefore, we have our HTML document, and as you can see, these are the previous siblings, which are exactly the same as the ones that have been displayed on the output window. So we were successful in extracting the previous siblings. Now that was all about navigating tags. There's another concept that we need to be clear about. It's known as navigable strings. Let's have a look what happens when we try to print soup.title. And as you can see, we have the entire tag along with the string web scraping. But what if you only want to extract web scraping and exclude the tags? That is, you do not want title to be displayed on the output screen. In order to do that, all you have to do is use the dot string attribute. So we use soup.title.string. Now let's try and execute this code and see what happens. And as you can see, now we have successfully extracted the string from the tag. Now the dot string attribute works fine if a tag's only child is another tag which contains a navigable string. However, if a tag contains more than one navigable string or more than one child, then it's not clear what the dot string should refer to. So the dot string won't work and will be defined to none. So what do I mean? Suppose we use the body tag, which has more than one children. In that case, let us try and visualize what's the output. And as you can see, we have none as the output. This is because body has several children and the interpreter is unable to decide what string it should refer to. In order to overcome this problem, you can use the strings generator. So let us go ahead and create the strings generator with the help of a for loop. So for string in soup dot body dot strings, and then let's print string. So I'm iterating over all the string elements within the body and then printing the string one by one. So let's try and have a look at the output. And as you can see, let me maximize the output screen. All the strings that are present within the body tag have been displayed on the screen for us. Now as you can see, we have a lot of new line characters between the strings or white spaces. So in order to get rid of these white spaces, you can use the stripped underscore strings generator instead of the dot strings generator. Now if that was confusing, I'll show you how that works. So instead of using strings, we are now going to use stripped underscore strings, and then we are going to print the string. So this will help us eliminate the new line characters and any other white space that we might want to remove from our string. Now let's try and execute this code. And as you can see, we now have all the strings successfully extracted without any new line character present between them. So that was all about tags and strings. Now in the next section of this course, we are going to discuss how we can search for elements within a given web page. So if you have time, please join me in the next lecture.